In this video, we'll be looking at how physics applies to the game of football. The first topic is throwing the actual ball. So, when the football travels through the air, it always follows a curved path because the movement of the ball in the vertical direction is influenced by the force of gravity. As the ball travels up, gravity slows it down and stops it briefly at its peak height. The ball then comes down and gravity accelerates it until it hits the ground. This is the path of any object that is launched or thrown and is called projectile motion. When you throw a football, gravity is at place. The gravity equation here is Fg equals g times m1 times m2 divided by r2. So when we look back and Mohammed is actually throwing the ball, you can see that gravity is at place. The next topic we're going to be covering is catching the actual football. When the football is catched, we see force in motion. When Noah catches the football, it hits him and causes an impact. As soon as Noah catches the ball, he runs for the touchdown but gets tackled by Sonny. This is showing multiple laws of physics, but we're only going to focus on just one. Since Sonny clearly had more momentum when he tackled Noah, it sent Noah flying in the air, causing him to fly and land further away. Like the Newton's first law states, an object in motion will stay in motion unless acted upon by an opposing force. Sonny here is clearly the opposing force. The force equation is F equals m times a, where m equals mass and a is acceleration. So when we look back at Noah getting tackled, the force, momentum, gravity, and acceleration are all taking place here.
Damn!
The last topic we're going to be covering is acceleration. When you run in the field, acceleration is taking place. What you see here is Trey running a 40-yard dash. When he runs, the force that is happening is acceleration. The formula for acceleration is final velocity minus initial velocity over time. As you see here, Trey is running faster and faster, which is causing his acceleration to increase. However, Trey only ran a 4.9 on the 40-yard dash. If we go back and you remember when Mohammed threw the ball, he was able to calculate how much strength he was going to need in order to throw the ball. But let's say that gravity was higher and he could not calculate how much strength he needed. If this were to happen, then the ball would not have reached Sonny, but instead fallen short. We see the same thing here again when Noah tried to throw it to Sonny but was not able to calculate the needed strength. This all goes to show how gravity relates to the throwing of a football and how it really affects whether the ball is going to get to the other person or not. I feel like I should go more into detail with force and acceleration, so let's talk about force first. A force is a push or a pull upon an object resulting from the object's interaction. Whenever there is an interaction between two objects, there is a force upon each of the objects. When the interaction ceases, the two objects no longer experience the force. Forces only exist as a result of an interaction. But forces are classified into two categories: contact forces or action at a distance forces. Contact forces are forces that happen when two interacting objects are in physical contact. Action at a distance forces are when two objects don't interact physically but are still able to push or pull on one another. A good example of this is magnets. Now, when Noah caught the ball, he experienced contact forces because he was in direct contact with the actual football. And when Noah was running to the touchdown and both his feet were off the ground, he was experiencing action at a distance forces. Now, this basically goes over how forces apply to physics and football.